Hello students, welcome to the third lecture on aldehyde, ketone and carboxylic acid chapter. In this third lecture, we will be going to discuss the properties of the aldehyde ketone. So today's lecture regarding the properties. There's two lectures we have discussed. First lecture we have discussed about the nomenclature of this aldehyde and ketones, and we have also discussed in the second lecture regarding the preparation of the aldehydes and ketones. Now that is the properties. First let us understand the physical properties of aldehyde and ketones. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Physical property. Methanol exists as a gaseous state, whereas ethanol exists as a volatile liquids. Other aldehyde and ketones, they exist either as a liquid or as a solid. The boiling point of the aldehyde and ketones is higher as compared to the other hydrocarbons like ethers or other hydrocarbons, because due to the presence of the dipole-dipole interaction in the aldehyde and ketone compound. But if we compare with the alcohol is having the higher boiling point as compared to the aldehyde and ketone, because in the alcohol there is a presence of the intermolecular hydrogen bonding, whereas in case of aldehyde ketone this type of formation of the hydrogen bonding is not there. Third thing, that is the solubility. The lower aldehyde and ketone up to the carbon chain, up to the carbon number of carbon atoms is 4, it is miscible in the water in all proportions. But after that, when the alkyl chain goes on increasing, that is number of carbon atom is more than 4, at the time the solubility of the aldehyde and ketone is found to be lower. It is found to be decreasing because of the increasing of the hydrocarbon parts of the compound. And while the aldehyde and ketone is miscible, is soluble in water, that is due to this fact there is a hydrogen bond, formation of the hydrogen bond between the water and the aldehyde or ketones. As for example, this is how this bond has been formed. Let us understand. This is the hydrogen molecule. This is the water molecule, and we are taking the case of this is the hydrogen bond, one hydrogen bond, and another hydrogen bond is between okay. So this is the hydrogen bond, and it formed the hydrogen bond with the water, and that is why this is a water molecule. That is why this is miscible, it is soluble in water. Now we are going to discuss the chemical properties of the aldehyde and ketones. First, we have discussed the physical properties. Secondly, we are going to discuss the chemical properties. As both the aldehyde and ketone is having the carbonyl group. This is the carbonyl group. So both the compounds will found having the similarity in the chemical reaction. They undergo the chemical reactions which are similar to each other. There are different chemical reactions that we are going to discuss. That is number one, that is the nucleophilic substitute nucleophilic addition reaction. Why the aldehyde and ketone going to undergo this nucleophilic addition reaction? Let us first understand. This is the carbonyl group. In the carbonyl group, you can observe there is a presence of the oxygen molecule. It is highly electronegative. So it will attract the electron pair towards itself, and it is having a slightly negative charge. Negative charge generated in the oxygen molecule, and there is a positive charge in the carbon atom. So carbon atom here acts as a electrophile. So it can easily take up the nucleophile towards itself, and it will form a intermediate. When the nucleophile will attack the carbon atom, the carbonyl group, it will, suppose this is a nucleophile, and in this nucleophile, when it is attacked this electrophile carbon atom, it will going to prepare a intermediate. This is called the tetrahedral alkoxide intermediate. This will form this is, you can write tetrahedral alkoxide. Tetrahedral alkoxide intermediate is formed. And this tetrahedral alkoxide, you can observe that it is negatively charged. So make it a neutral species. So it will take up H plus ion from the reaction bar, and it will going to produce a addition product. This is a addition product where you can see this is the addition of nucleophile and the addition of H plus ion, and it will going to produce a addition product. Now the reactivity of this nucleophilic addition reaction is found to be different from the aldehyde and ketones, or you can see the in case of the aromatic aldehyde and ketone. So what is the reaction, what is the reactivity, that let us understand. If we arrange in the decreasing order of the reactivity of these aldehyde and ketones towards this nucleophilic addition reaction, so we can write this in order of decreasing their reactivity. This is, we can write the order of reactivity. Order of reactivity is this: formaldehyde is highly reactive towards this nucleophilic addition reaction, followed by CH3CHO, followed by, that is, CH3CO acetone, and afterwards you can see that there will be the decreasing of the reactivity of this aldehyde and ketone. Now question arises, why it is so? Why formaldehyde is highly reactive towards this nucleophilic addition reaction, and why acetone is the least reactive? And reason behind this, there is the two effect that we have to understand. First, that is a steric effect. And second is plus I effect, inductive effect of the alkyl group. Why steric effect going to reduce the reactivity of this compound? That is due to this fact, if we compare with the formaldehyde and the acetone, what we find, that there is a bulky group, that is CH3 group, and this is 2 CH3 group in this ketone. Whereas in case of formaldehyde, there is no such group. So nucleophile can easily approach to this formaldehyde as compared to this acetone, where there is a two higher groups. And here also you can see CH3CHO, in the acetaldehyde, there is only a bulky group, that only one bulky group, that is CH3. So nucleophile can easily approach to this positively charged electrophile, carbonyl atom carbon, and it will able to contact with this carbonyl carbon atom carbon, and it will able to form the bond. So due to this steric effect, you can see the decreasing order of the reactivity of these pieces. And plus I effect means that CH3 group, alkyl group, has a tendency of releasing the electron. It can able to donate the electron. So here, when it donate the electron, what is going to happen? The electrophilicity of the carbon atom is going to decreases. So here 2 CH3 group means it will release the electrons to this carbonyl carbon atom, and its electrophilicity going to be reduces, and that is why also due to this plus I effect, this is called the plus I effect, the electrophilicity is decreasing, and there is a reactivity towards this nucleophilic addition reactions will be lower. So there is a two effects you can see, and this has been also observed for the benzaldehyde. In case of benzaldehyde, it is also found that is less reactive if we compare with this acetone or acetaldehyde, not formaldehyde, because there also you can see, in case of benzaldehyde, you can see this is the benzaldehyde, Here also you can see this impact because the electron this is a in the benzene ring you can see there is a free electrons. These are basically free electrons, and this electron will move to this position, and this is basically a plus R effect. Due to this plus R effect, it will going to donate the electron. The electron is moved through this bond and it will create a double bond here. So it will create a double bond. This electron will shifted there, this electron shifted there minus. So what we observe, the electrophilicity of this carbon atom goes on decreasing, and that is why its reactivity will be reduces. So we understand the nucleophilic addition reaction, how the nucleophilic addition reaction is being undergone by the acetaldehyde or any type of aldehydes or ketone or benzaldehyde, and what is their reactivity. That every compound, every species has not the same type of reactivity. Its reactivity also changes, and that is being influenced by the two effects. One, that is the steric effect, and other is Plaza effect. Now we are going to discuss some very important reactions, that is nucleophilic addition reaction, that is undergo by these compounds. To discuss the addition of hydrogen cyanide, addition of HCl, and this reaction is catalyzed by base, because if we make this reaction with the pure HCl, the reaction rate will be very much slow. For that, it has been catalyzed by a base. So HCl plus, when it react with a base, it will going to produce the Cn minus, that is the nucleophile, and H2O. And this is going to react with the carbonyl group, and it will be going to form a intermediate, and this, when with H plus ion, it will going to produce this. The name of this compound is cyanohydrin. Cyanohydrin. Name of the compound is cyanohydrin, and it is a useful intermediate. Different types of product has been prepared from this intermediate. As for example, this is acetaldehyde, and when it is in this reaction, you can see the pH has been kept 9 to 10, because we have already discussed pure HCl, there is a difficulty because of the rate of the reaction will be very much slow. For that, we need the pH of 9 to 10, means in the basic solution. So when we add this, it will going to form and when this is called the acetaldehyde acetaldehyde cyanohydrin, acetaldehyde cyanohydrin, and when this is hydrolyzed, and this is a optical active organic compound, because you can see this is a chiral center, this is a chiral carbon atom, because all the four groups are different, so it will show optical activity. And when it is hydrolyzed, it is going to produce the alpha hydroxy acid, that is the lactic acid. This is here you can able to see it will produce the lactic acid, and it exists as a racemic mixing because this is an optical active. So this product, when we add the HCl, it will going to produce this cyanohydrin, and cyanohydrin is a very useful intermediate. Second reaction, that is addition of sodium hydrogen sulfide. Sodium hydrogen sulfide, this is the reaction is here nucleophile will be is HSO3 minus, and this will be Na plus, and here will be addition, the reaction compound will be ONA plus and HSO3, and this reaction is reversible reaction. This is a reversible reaction, and this step is there is proton transfer reaction. This the proton has been transferred. This H plus will be replaced by this sodium, and you will get OH and this is bisulfite compound, and it exists as a crystalline. It is a solid compound, and a crystalline compound. It is soluble in water, and when we hydrolyze in acid, it will going to reproduce back this aldehyde. Both aldehyde and ketone going to undergo this type of reaction, and for ketone, the reaction, this is a reversible reaction. The reaction is being conducted, reaction is being proceed in the equilibrium is left hand side direction, right hand side direction for the aldehyde, and for the ketone it is on the left hand side direction. Equilibrium will be mostly on the left hand side direction. So from the aldehyde and ketone we can able to separate from these reactions also. And from this reaction also we can able to purify the aldehyde of ketone from the non-carbonyl compound. Okay. Now the third reaction, that is addition of Grignard reagent. Grignard reagent. This also we have discussed when we are discussing the preparation of alcohol. In this process, by addition the Grignard reagent with the acetaldehyde or ketone, we can able to produce the alcohol. That is the secondary alcohol and the tertiary alcohol, which is also discussed when we are discussing the alcohol, preparation of alcohol. Fourth is addition of alcohol. In this case, first we discuss the addition to the aldehyde. Aldehyde will react with the monohydric alcohols. So his reaction is this. This is aldehyde, and in presence of dry HCl, and this is the alcohol. Here alkoxy ion acts as a nucleophile. So it is going to produce OR dash and OH. This is called alkoxy alcohol. This is the intermediate alkoxy alcohol, or this is called hemiacetal also. Hemiacetal. It is further been reacted with another molecule of alcohol in presence of dry HCl. And another molecule of alcohol. It is going to produce this product. This is called acetal. Or this is also called JEM dialkoxy alcohol. JEM dialkoxy alcohol, or it is famous as acetal. Okay. Next that we are going to discuss the addition with the ketone. That is, we are taking this is ketone, diHCl, and we have to take this reaction is this. This is ethylene glycol, and in presence of the dry HCl, it will eliminate one molecule of water, and it will going to produce this. This is called ethylene glycol ketal. This is called ethylene glycol ketal. Here it is acetal, here it is ketal. Both the compound, you can see added compound is basically a ether. So it is highly resistant to the alcohol. So this reaction is normally being carried out to protect the aldehyde or ketone group, carbonyl group. And this, when we are going to hydrolyze it with the mineral acid, this can be easily returned back to the original form, original aldehyde or ketone. Okay. Addition of ammonia and its derivative. That is, you can write this. The speciality of this reaction, the addition will occur. After that, there will be a elimination reaction, elimination of one molecule H2. So first let us understand its reaction. This is carbonyl group, and with this the addition reaction will be this. There is an intermediate reaction, this NH2 and this. This is the intermediate addition reaction, and here one molecule of H2 is eliminated, and you can observe there is a formation of this, and there is a carbon nitrogen double bond is produced. Now, depending on these substituents to this ammonia, that is jet, this has a different type of compounds that you can observe. This is jet. Jet means that is the substituents to the ammonia, and this is the reagent. Carbonyl derivative, and name of this compound. When J, that is the substituent, is H, means this will be the NH3, or you can say this is ammonia. This is ammonia. And the carbonyl derivatives is H. Just we are replacing the jet with this jet. Suppose here it is a H. So name of this imine. Next, that is, suppose the substituent is R. At that time the reagent name is amine. So carbonyl derivatives will be this. So the name of this compound, this carbonyl derivative, is basically it is a substituted of amine. Substituted amine, or another name, this is given, this is Schiff's base. Schiff's base. Okay. When it is derivative, when it is OH, At that time reagent is hydroxylamine. Hydroxylamine. And compound, this compound is NOH, and this is name of this compound is oxime. Okay. Now substituent is NH2 and name of this hydrazine. At that time this name of the compound will be hydrazone. This is name of this phenylhydrazine. Phenylhydrazine, and compound is this phenylhydrazone. Okay. Now this is semi-carbazide. And reagent is semi-carbazide and carbonic derivative is name will be semi-carbazone. Okay. So this is the compounds that is formed by the ketones, aldehyde and ketones, and here you can see there is a carbon nitrogen double bond, and we have to put these substituents and we will get this type of compounds. When there is a ammonia reagent, at that time we will get the amine. When there is a alkyl group, we will get the substituted amine. OH group present. This is basically what we are doing. We are replacing one hydrogen atom of the ammonia with these substituents. That is OH, NH2, this substituent and this substituent, and this reagent name is this. Right? So this we are getting all these products. So I think what we have discussed, that is clearly been clear to you. If you have any problem, if you have any doubts, that you can comment in the comment sections. In the next lecture, we will going to discuss other remaining properties, chemical reactions that is being undergo by this aldehyde ketone, that we will discuss. Thank you very much for watching.